Have you ever wondered what it would mean if something was deliberately sent to find us? Not just stumbling into our cosmic neighborhood by accident, but actually called here, summoned across the vast emptiness between stars by signals we never meant to send. On July 1st, 2025, astronomers detected something extraordinary racing toward our solar system at impossible speeds. They named it 3IATLAS, the third confirmed visitor from interstellar space. But this wasn't just another wandering chunk of cosmic debris. This massive object, stretching over 11 kilometers across, arrived with timing so precise it defies explanation. Its trajectory so perfect it seems engineered. Its behavior so unusual that it's forcing scientists to question everything they thought they knew about what's possible in the depths of space. What if 3IATLAS didn't just happen to find us? What if it was called here by something we've been doing for over a century without realizing the consequences? Tonight, we're going to explore a possibility that could reshape our understanding of our place in the universe forever. Before we dive into this cosmic mystery, I'd love to know where you're watching from. Drop a comment below, telling me your location and what time it is where you are. There's something profound about knowing that people all around the world are contemplating these same mind-bending questions together under the same starlit sky. Make sure to hit that like button if mysteries like this fascinate you, and subscribe because we're just getting started on a journey that might change how you look at every point of light in the night sky above us. For the past 123 years, humanity has been broadcasting into space, whether we intended to or not. Every radio transmission, every television signal, every powerful radar pulse we've ever sent has been leaking into the cosmos at the speed of light, creating an expanding bubble of human noise that now extends roughly 130 light-years from Earth in all directions. Most of us never think about this electromagnetic signature we're painting across the galaxy. When you turn on your radio or stream a show on your phone, you're not considering that those signals don't just stop at your device. They bounce off satellites, leak through the atmosphere, and continue their journey into the infinite darkness between stars, carrying with them the sounds and stories of human civilization. But what if someone out there has been listening? The story begins with our first intentional message to potential alien civilizations. In 1974, scientists at the Arecibo Observatory in Puerto Rico aimed their massive radio telescope at a cluster of stars called M13 and transmitted a carefully crafted signal containing basic information about humanity. The message included our counting system, the structure of DNA, a crude representation of a human figure, and a map of our solar system, with Earth clearly marked as the third planet from our Sun. It was meant to be ceremonial, really. M13 is 25,000 light-years away, so even if someone received our message and responded immediately, we wouldn't hear back for 50,000 years. But that deliberate transmission represented something profound, humanity's first conscious attempt to announce our presence to whatever intelligences might exist among the stars. However, our accidental broadcasts started much earlier and have been far more revealing. Since the early 1900s, every powerful radio transmission has been painting an increasingly detailed picture of our technological development for anyone with the capability to detect and decode these signals. Think about what our electromagnetic signature reveals about us. The progression from simple radio broadcasts in the 1920s to television in the 1940s, then satellite communications, cellular networks, and powerful radar systems designed to track objects in space. Any civilization monitoring our region of the galaxy would have witnessed our rapid technological evolution in real time, delayed only by the speed of light. Our most powerful transmissions come from planetary defense systems, massive radar installations designed to track asteroids and other potentially dangerous objects. When these systems pulse their energy into space, they create some of the brightest artificial radio sources in our local galactic neighborhood. They're essentially cosmic lighthouses, sweeping their beams across the sky with each rotation of our planet. The Arecibo Observatory, before its collapse in 2020, was capable of generating radio signals so powerful that they could theoretically be detected by similar facilities across interstellar distances. The Deep Space Network, with its enormous antennas in California, Spain, and Australia, routinely communicates with spacecraft at the edge of our solar system, using transmissions that would shine like beacons to any advanced civilization within dozens of light years. But here's where the story takes a fascinating turn. In October 2017, we detected our first confirmed visitor from interstellar space. The object was given the Hawaiian name ʻOumuamua, meaning scout or messenger from afar arriving first. Its name turned out to be remarkably prophetic. ʻOumuamua was unlike anything we'd ever seen. It was tumbling end over end as it raced through our solar system, its brightness varying by factors of 10, suggesting an extremely elongated shape, like a cosmic cigar or perhaps something even more unusual. Most puzzling of all, it was accelerating in ways that couldn't be explained by the sun's gravity alone, as if something was giving it an extra push. The object showed no signs of the gas and dust emissions typical of comets, yet something was clearly acting on it. Harvard astronomer Avi Loeb suggested it might be a light sail, a thin reflective surface designed to catch stellar radiation for propulsion, the kind of technology that an advanced civilization might use for interstellar travel. Oumuamua's trajectory was also remarkable. It had approached from the direction of the star Vega, but the timing didn't work out for a simple ejection from that system. More intriguingly, its velocity relative to the local galactic environment was unusually low, just 6 kilometers per second. Most objects ejected from other star systems would be expected to move much faster. It was almost as if Oumuamua had been positioned exactly where our solar system would encounter it. The probability of such a low velocity occurring naturally has been calculated at less than 1%. This near-stationary state in galactic terms meant that Oumuamua wasn't just any random piece of interstellar debris. It was either an incredibly rare natural occurrence, or it was something that had been deliberately placed in a position where our solar system would inevitably encounter it. Then, in 2019, we detected our second interstellar visitor, designated 3I Borisov. This object behaved more like a conventional comet, with a visible tail and outgassing that followed predictable patterns. It seemed to confirm that most interstellar objects would be natural, if unusual, but 3I Borisov also raised new questions. Its chemical composition was different from comets in our solar system, suggesting formation in a much colder environment around a different type of star. We were seeing direct evidence that planetary systems throughout the galaxy produce very different types of objects under very different conditions. The stage was set for something even more extraordinary. On July 1st, 2025, the ATLAS survey telescope in Chile detected a faint point of light moving against the stellar background. Within hours, follow-up observations confirmed what astronomers had hoped to see, but hardly dared expect. Another interstellar visitor, the largest one yet discovered. They designated it 3IATLAS, and almost immediately it became clear that this object was different from its predecessors in fundamental ways. Where Oumuamua was perhaps a few hundred meters long, 3IATLAS stretched over 11 kilometers across. If Oumuamua was a scout ship, 3IATLAS was a battleship, or perhaps more appropriately, a massive cargo vessel capable of carrying substantial payloads across interstellar distances. The size estimates underwent several revisions as more sophisticated observations became available. Initial calculations suggested the object might be as large as 20 kilometers across, though more precise measurements later refined this to approximately 11.2 kilometers. Even at this revised size, it remained by far the largest confirmed interstellar object ever detected. Unlike Oumuamua's chaotic tumbling, 3IATLAS rotated with clockwork precision. Its rotation period of 16.16 hours remained stable throughout months of observation, varying by less than a few minutes. This rotational stability suggested either a very recent origin protection from disruptive forces during its journey, or an internal structure specifically designed to maintain stability. The object's trajectory told an equally remarkable story. Tracing its path backward through space, astronomers determined that 3IATLAS had originated from a region associated with the thick disk of our galaxy, an ancient stellar population formed when the Milky Way was younger and contained fewer heavy elements than it does today. But perhaps most intriguingly, 3IATLAS was approaching our solar system on a trajectory that seemed almost too convenient to be natural. It was traveling in a retrograde orbit, opposite to the direction of planetary motion, while remaining precisely aligned with the plane of our solar system. This alignment is statistically improbable for a random interstellar visitor. The probability that a randomly oriented trajectory would align so closely with our solar system's plane by chance is less than a few percent. If 3IATLAS were an artificial object designed for a controlled approach to our solar system, this would be exactly the type of trajectory a mission planner would choose. The retrograde orbit would allow for efficient gravitational deceleration, while the alignment with our solar system's plane would minimize the risk of collision with asteroids or other debris. The timing of 3IATLAS's arrival also raises profound questions. The object's current trajectory suggests it has been traveling through interstellar space for millions of years, yet it arrives precisely when human civilization has developed the capability to detect and study such visitors in detail. We're living through the brief window in human history when we have the technology to find these objects but are still surprised by their properties. This timing could be coincidental, but it fits remarkably well with a scenario in which 3IATLAS was dispatched in response to signals transmitted from our solar system in the relatively recent past. The 8-year gap between ʻOumuamua's passage and 3IATLAS's arrival is sufficient for information to travel several light years and for a responsive mission to be launched. Could ʻOumuamua have been that first reconnaissance mission, testing our solar system's defenses and capabilities? Could it have transmitted information back to whoever sent it, prompting the dispatch of a larger, more capable vessel? The concept isn't as far-fetched as it might initially seem. If an advanced civilization had positioned monitoring stations throughout our galactic neighborhood, they could potentially detect signs of technological activity in nearby stellar systems and dispatch response missions with travel times measured in thousands rather than millions of years. What makes this scenario even more compelling is the apparent optimization of 3IATLAS's approach for observation and study. Its trajectory provides months of visibility from Earth-based telescopes. Unlike ʻOumuamua, which was discovered just weeks before, it disappeared beyond the reach of our instruments. As 3IATLAS continues its journey through our solar system, every new observation adds another piece to a puzzle that grows more intriguing with each passing day. We're witnessing something unprecedented, the arrival of a massive object from interstellar space that challenges every assumption about what such visitors should look like and how they should behave. The question that haunts astronomers and captivates the public imagination is elegantly simple yet profound in its implications. Are we witnessing the greatest coincidence in cosmic history, or are we seeing the first evidence of intelligence operating on interstellar scales? In our next segment, we'll dive deeper into the physical characteristics of 3IATLAS that have left scientists struggling to explain how such an object could exist and behave as it does. We'll explore the dust production that initially baffled researchers, the unusual composition that links it to the earliest epochs of our galaxy's history, and the growing debate over whether we're looking at the most exotic natural object ever discovered or something far more extraordinary. The physical properties of 3IATLAS tell a story that grows stranger with every measurement. When astronomers first began studying this interstellar giant in detail, they encountered something that shouldn't exist according to our understanding of how objects behave in space. Picture this: an 11-kilometer wide object hurtling through the vacuum of interstellar space at speeds that would cross the entire United States in under 3 minutes. That's the scale we're dealing with here. But size is just the beginning of what makes 3IATLAS so extraordinary. The first mystery emerged when telescopes detected a massive dust cloud surrounding the object, what astronomers call a coma. This dusty envelope stretched thousands of kilometers from the central nucleus, creating a ghostly shroud that made 3IATLAS visible even to modest ground-based telescopes, despite its enormous distance from Earth. Here's where things get weird. Dust doesn't just magically leap off the surface of celestial objects. It needs to be carried away by something, typically gases that vaporize when heated by solar radiation. When comets approach the Sun, water ice and other frozen materials sublimate, transition directly from solid to gas, creating jets of vapor that drag dust particles along for the ride. But when astronomers pointed their most sensitive spectrographs at 3IATLAS, searching for the telltale signatures of these gases, they found nothing. No water vapor, no carbon monoxide, no carbon dioxide, none of the molecular fingerprints that should accompany such dramatic dust production. This wasn't just unusual, it was theoretically impossible according to everything we know about how comets work. You can't have dust without gas. It's like finding smoke without fire, rain without clouds, or shadows without light sources. For months, this paradox stumped researchers worldwide. Some proposed exotic explanations involving electromagnetic effects or thermal expansion mechanisms that could somehow eject dust without requiring sublimating gases. Others wondered if 3IATLAS might be composed of materials so pure or unusual that their sublimation products were invisible to our instruments. The breakthrough came from observations in the near-infrared spectrum, where Earth's atmospheric interference is minimal. High-resolution spectrographs finally detected what everyone had been looking for, but not in the form they expected. Instead of gas, they found abundant water ice grains within the dust cloud itself. The solution was elegant once understood. Rather than completely vaporizing into invisible gas, the ice in 3IATLAS was only partially sublimating, creating tiny crystalline particles that were ejected along with conventional dust. These ice grains were large enough to survive in space for extended periods, but small enough to be carried away by the minimal vapor pressure created by their own slow sublimation. Think of it like steam rising from a hot cup of coffee on a cold morning. Under the right temperature conditions, water can exist simultaneously as liquid, vapor, and tiny suspended droplets. 3IATLAS was experiencing a similar phase transition, but with ice instead of liquid water. This discovery revealed something profound about the object's composition. To sustain such activity levels, 3IATLAS had to contain enormous reserves of water ice, essentially making it a giant dirty iceberg from another star system. But here's what makes this truly remarkable. Most models of interstellar travel suggest that objects would lose their volatile materials through sublimation and radiation damage during journeys lasting millions of years. Yet 3IATLAS arrived with its ice reserves largely intact. This preservation implies either exceptional protection from space weathering or a more recent departure from its origin system than its trajectory initially suggested. The object appears to be composed of approximately 70% dark, carbon-rich materials and 30% water ice, a composition that matches some of the most primitive objects in our own solar system. The spectroscopic analysis revealed another crucial detail. 3IATLAS shows a distinctive reddish color that indicates the presence of complex organic compounds altered by eons of cosmic radiation exposure. This chemical signature links it to the earliest epochs of our galaxy's formation, when stars contained fewer heavy elements and planetary systems formed under very different conditions than those that created our solar system. But perhaps the most intriguing aspect of 3IATLAS's physical properties is its rotational behavior. The object spins with a period of exactly 16.16 hours, and this rotation has remained stable throughout months of observation, with variations of less than a few minutes. This precision is extraordinary for any natural object, especially one that has been wandering through space for millions of years. Natural asteroids and comets typically exhibit irregular rotation due to impacts, outgassing, and the subtle effects of radiation pressure. The fact that 3IATLAS maintains such clockwork regularity suggests either recent formation, exceptional structural integrity, or deliberate design for rotational stability. The modest brightness variations observed during each rotation indicate a shape much closer to spherical symmetry than ʻOumuamua's extreme elongation. Current models suggest we might be viewing 3IATLAS nearly pole-on, meaning we're looking down at one of its rotational axes rather than seeing it from the side. This viewing geometry would minimize apparent shape changes during rotation, but it also makes determining the object's true three-dimensional structure challenging. If this orientation is intentional rather than coincidental, it raises fascinating questions about the nature of our observation. The pole-on view would minimize the structural information we can gather while still allowing us to detect the object's presence and basic properties. The dust production itself follows an unusual pattern. Unlike typical comets that develop roughly spherical dust clouds, 3IATLAS exhibits what astronomers describe as a forward-facing fan of material. This asymmetric structure appears to result from the object's slow rotation, which allows one hemisphere to be heated more intensely by solar radiation than the other. As 3IATLAS rotates with its 16-hour period, different regions of its surface experience prolonged exposure to sunlight. Unlike faster rotating objects that heat relatively uniformly, this slow rotation creates pronounced temperature differences between day and night sides. These temperature variations drive the sublimation process, with the most active regions located on the sunward hemisphere. The forward-facing orientation of the dust fan suggests that heated material is being carried into the object's orbital motion, creating the observed asymmetric pattern. The physics behind this behavior provides insights into both composition and thermal properties, confirming that 3IATLAS contains substantial volatile materials despite its interstellar origins. The sheer scale of dust production is impressive by any measure. During peak activity periods, 3IATLAS was estimated to be shedding several tons of material per second. This sustained outgassing over many months indicates that volatile substances are distributed throughout the object's interior rather than being concentrated in a thin surface layer. Such distribution is consistent with formation in a cold, low-gravity environment where ice and dust could accumulate gradually over extended periods. It suggests origins in the outer regions of an ancient stellar system, far from the central star where water would remain frozen and organic compounds could survive without being broken down by intense radiation. The preservation of these profound questions about the object's history materials through an interstellar journey raises and the mechanisms that protected it during its voyage between stars. The challenges of such a journey are immense. Exposure to cosmic radiation that can break apart molecular bonds, temperature extremes ranging from near absolute zero to solar heating, potential impacts with interstellar dust and debris, and the mechanical stresses of gravitational encounters with other stellar systems along the way. Yet, 3IATLAS has arrived with its structure and composition largely intact. The object's size may provide much of this protection. Larger objects have lower surface area-to-volume ratios, meaning that radiation damage and thermal effects penetrate only a small fraction of their total mass. At 11 kilometers across, 3IATLAS would be essentially immune to all but the most catastrophic encounters during its interstellar journey. But size alone doesn't explain everything. The stable rotation, the preserved ice reserves, and the organized dust production patterns all suggest a level of structural integrity that challenges our understanding of how natural objects should behave after millions of years in the harsh environment of interstellar space. As observations continue and more sophisticated analysis techniques are applied to the wealth of data being collected, 3IATLAS continues to challenge fundamental assumptions about what interstellar objects can be and do. Its combination of enormous size, stable behavior, and complex activity patterns marks it as something entirely new in our experience with visitors from other star systems. Whether these characteristics represent the natural evolution of an ancient comet under exotic conditions or evidence of something more deliberately constructed remains the subject of intense scientific debate. But there's no question that 3IATLAS represents a new category of cosmic visitor, one that demands new approaches to observation, analysis, and interpretation. The implications extend far beyond this single object. If interstellar space contains populations of such massive, well-preserved visitors from other stellar systems, it suggests that the galaxy is far more dynamic and interconnected than we previously imagined. Materials and possibly even information may be routinely transported between star systems on timescales that dwarf human civilization, but are brief moments in cosmic terms. In our next segment, we'll explore the growing scientific debate over 3IATLAS's true nature and examine the evidence that some researchers believe points toward artificial rather than natural origins. We'll delve into the statistical arguments about trajectory and timing, the technological challenges that would face any civilization attempting interstellar missions, and the broader implications for our understanding of intelligence and technology on galactic scales. The question we're grappling with isn't just what 3IATLAS is, its place in a but what it means for humanity universe that may be far less empty and far more purposeful than we ever dared imagine. The scientific community finds itself at a crossroads unlike any in modern astronomy. When 3IATLAS first appeared in our telescopes, most researchers expected it would follow the pattern established by previous interstellar visitors. They assumed it would be strange, certainly, but ultimately explainable through natural processes we already understand. Instead, every new measurement has deepened the mystery. Dr. Avi Loeb, the Harvard astrophysicist who first proposed that ʻOumuamua might be artificial, has been closely following 3IATLAS since its discovery. His analysis focuses on what he calls the coincidence problem, the statistical improbability of so many unusual factors aligning by pure chance. Consider the trajectory alone. Objects ejected naturally from other star systems should arrive from random directions, reflecting the chaotic nature of galactic dynamics. Yet 3IATLAS approaches from a direction that places its origin in one of the galaxy's oldest stellar populations, following a path that's optimized for efficient deceleration in our solar system. The probability calculations are stark. Random interstellar objects have less than a 2% chance of aligning so precisely with our solar system's orbital plane. They have virtually no chance of maintaining the stable rotation periods we observe, and they certainly shouldn't arrive with such convenient timing for detailed study by Earth-based observers. But perhaps most compelling is what researchers call the preservation paradox. Computer models of interstellar travel consistently predict that objects should lose most of their volatile materials during journeys lasting millions of years. The radiation environment of deep space, while sparse by terrestrial standards, contains enough high-energy particles to gradually erode exposed ice and break down organic compounds. Yet 3IATLAS retains approximately 30% water ice after what appears to be an extraordinarily long journey. This preservation suggests either protection mechanisms we don't understand or a much more recent departure from its origin system than its trajectory implies. The artificial hypothesis proposes that these aren't coincidences at all, but design features. An interstellar probe would naturally be engineered for maximum durability, optimal trajectory planning, and stable operation across vast distances and time periods. The characteristics that make 3IATLAS unusual as a natural object make perfect sense if it represents technology designed for interstellar reconnaissance. Loeb points to the object's apparent optimization for observation as particularly significant. Unlike ʻOumuamua, which was discovered just weeks before disappearing beyond telescopic range, 3IATLAS provides months of study time. Its approach trajectory maximizes visibility from Earth while maintaining safe distances from our planet. If you were designing a probe to study a newly detected technological civilization, this is exactly how you would plan the mission. Close enough for detailed observation, distant enough to avoid detection as artificial, and visible long enough to gather comprehensive data about the target system's capabilities and responses. The mainstream astronomical community remains deeply skeptical of such interpretations. The principle known as Occam's razor suggests that natural explanations should be preferred over extraordinary ones. An artificial origin certainly qualifies as extraordinary. Most researchers continue to believe that exotic natural processes can account for 3IATLAS's unusual properties. Dr. Alan Fitzsimmons at Queen's University Belfast has led efforts to find natural explanations for the object's behaviour. His team's models suggest that 3IATLAS could represent a new class of interstellar comet, one formed under conditions so different from our solar system that its properties seem alien to us. The thick disk origin supports this interpretation. That ancient stellar population formed when our galaxy contained much lower concentrations of heavy elements. Planetary systems developing in such environments would naturally produce objects with compositions and structures, unlike anything familiar to us. The preservation of volatile materials, while challenging to explain, isn't necessarily impossible through natural means. If 3IATLAS formed as a loose aggregate of smaller icy bodies, internal insulation could protect deep reserves from space weathering. Alternatively, if it originated from a stellar system much closer than its trajectory suggests, the preservation problem becomes more manageable. The stable rotation might result from the object's large size and relatively spherical shape. Unlike smaller, irregularly shaped bodies that tumble chaotically, massive objects with balanced mass distributions can maintain stable spin states for extended periods. But the natural interpretation faces its own statistical challenges. Even if we accept that such exotic objects can form and survive interstellar travel, the timing of their arrival during humanity's brief technological window remains puzzling. We've had the capability to detect interstellar visitors for less than a century out of the 4.5 billion year history of our planet. This timing problem has led some researchers to propose what's called the observation selection effect. Perhaps interstellar objects have been passing through our solar system regularly for billions of years, but we're only now noticing them because we've developed the necessary detection capabilities. The expected discovery rate from future surveys supports this interpretation. The Vera Rubin Observatory, when fully operational, is projected to detect dozens of interstellar objects annually. If such visitors are indeed common, our recent discoveries might simply reflect the natural result of improved technology rather than any special significance in timing. Yet the artificial hypothesis continues to gain consideration, if not acceptance, within certain segments of the scientific community. The Pentagon's recent acknowledgement of unidentified aerial phenomena and the establishment of official programs to investigate anomalous objects have created a more open environment for discussing unconventional possibilities. The technological challenges facing any civilization attempting interstellar missions remain formidable. Accelerating large objects to the velocities required for interstellar travel demands enormous energy expenditures. Maintaining structural integrity and operational capability across million-year journeys requires materials, science, and engineering far beyond human capabilities. But proponents of the artificial hypothesis argue that these challenges, while daunting by current human standards, might not be insurmountable for civilizations with thousands or millions of years of technological development. The exponential pace of human technological advancement over just the past century demonstrates how quickly seemingly impossible achievements can become routine. More significantly, the artificial hypothesis doesn't require active propulsion throughout the entire journey. Once accelerated to interstellar velocities, objects coast through space under their own momentum. The challenge becomes navigation and course correction over vast distances and time periods, not continuous propulsion. Light sail technology, which Loeb originally proposed for ʻOumuamua, could provide both propulsion and navigation capabilities using only stellar radiation. A sufficiently large reflective surface could harness radiation pressure for gentle but persistent course corrections, while serving dual purposes as a communication antenna. The debate has been further complicated by the discovery of what some researchers interpret as potential signals from 3IATLAS. Radio telescopes monitoring the object have detected intermittent narrow-band emissions near frequencies traditionally associated with hydrogen, the most abundant element in the universe. These signals are weak and sporadic, appearing for brief periods before disappearing again. They could represent natural plasma phenomena associated with the object's interaction with solar radiation and magnetic fields. But their frequency characteristics and timing patterns have raised eyebrows among researchers familiar with theoretical frameworks for interstellar communication. The signals don't contain obvious information content or modulation patterns that would definitively indicate artificial origin, but their mere presence adds another layer of intrigue to an object already bristling with anomalies. Independent analysis teams using different radio telescopes and processing techniques have confirmed the emission's reality, eliminating the possibility of instrumental artifacts or local interference. Whatever is producing these signals, it's definitely associated with 3IATLAS itself. The polarization characteristics of the radio emissions suggest they originate from structured rather than random processes. Natural emissions typically show chaotic polarization patterns, while the 3IATLAS signals display organization that's difficult to explain through conventional plasma physics. Some researchers have proposed that the emissions result from the object's rotation interacting with charged particles in its dust coma, creating a natural but unusual form of radio lighthouse effect. Others suggest that magnetic field interactions could produce the observed patterns without requiring artificial explanation, but the artificial interpretation sees these emissions as potentially deliberate transmissions, either navigation beacons, status reports, or attempts at communication with whoever might be monitoring the object's passage through our solar system. The polarization patterns, if interpreted as intentional signals, could represent a form of modulation designed to convey information while maintaining plausible deniability as natural phenomena. Advanced civilizations might prefer such subtle communication methods to avoid triggering defensive responses from less developed species. The timing of the radio emissions also correlates with 3IATLAS's rotation period, but not in the simple way expected from natural processes. Instead of constant emission as different parts of the object face various directions, the signals appear and disappear according to more complex patterns that suggest active control rather than passive rotation effects. These observations have prompted proposals for more intensive monitoring using arrays of radio telescopes working in coordination. Such observations could potentially detect modulation patterns or information content that individual telescopes might miss. The challenge lies in distinguishing between genuinely anomalous signals and the natural electromagnetic environment of space. Interstellar objects interact with solar wind, magnetic fields, and cosmic radiation in ways that can produce complex and sometimes organized appearing phenomena without any underlying intelligence. The scientific method demands extraordinary evidence for extraordinary claims, and the radio emissions, while intriguing, don't yet meet the threshold required to support artificial origin conclusions. But they add another data point to a growing collection of observations that challenge purely natural explanations. As 3IATLAS continues its passage through our solar system, the debate over its nature reflects broader questions about our cosmic environment and our methods for investigating it. Are we witnessing natural phenomena that push the boundaries of our current understanding? Or are we seeing evidence of intelligence operating on scales we've never encountered before? The answer to that question may ultimately depend not just on what we observe about 3IATLAS, but on what future interstellar visitors reveal about the patterns and purposes that might govern such encounters. In our next segment, we'll explore what it would mean for humanity if 3IATLAS truly was called here by our electromagnetic emissions, and examine the profound implications such a scenario would have for our understanding of intelligence, technology, and communication on galactic scales. We'll also look at the practical questions facing scientists and policymakers if we're indeed being visited by representatives of another civilization. The stakes of this debate extend far beyond academic curiosity. If we're wrong about 3IATLAS being natural, we might be missing the most important discovery in human history. If we're wrong about it being artificial, we might be wasting precious resources chasing shadows in space. Either way, the arrival already changed how we think about our place in the galaxy of this mysterious visitor from the depths of interstellar space and what might be possible in the vast darkness between the stars. But what if we've been looking at this all wrong? What if the question isn't whether 3IATLAS could be artificial, but whether our entire understanding of how civilizations might communicate across interstellar distances needs to be completely reimagined? Think about how we communicate on Earth. When you want to send a message across an ocean, you don't load up a ship with a handwritten note and hope it arrives someday. You use radio waves, fiber optic cables, satellite networks, technologies that can bridge vast distances almost instantaneously. But what if the distances are so vast that even light itself becomes painfully slow? The nearest star to our Sun is over 4 light-years away. That means even if we sent a radio message at the speed of light, it would take 4 years to get there and another 4 years to receive a reply. For most stars in our galactic neighborhood, we're talking about communication delays measured in decades or centuries. But physical objects, while much slower than radio waves, have certain advantages that pure information signals don't possess. They can carry complex payloads, operate autonomously for extended periods, and most importantly, they can gather information about their destinations that remote observations could never provide. Imagine you're part of a civilization that's been monitoring radio emissions from promising star systems for thousands of years. You've detected the electromagnetic signature of a young technological species, us, and you want to learn more. You could try sending radio messages, but given the vast distances and time delays involved, a conversation would span centuries. Instead, you might choose a different approach entirely. You might send physical scouts. This is where the timing of our interstellar visitors becomes truly remarkable. Our first confirmed detection of such an object came in 2017, just as our observational capabilities had reached the threshold necessary to spot them reliably. Before that window, we might have missed them entirely. After it, we'll have instruments sensitive enough to detect them years in advance. It's as if someone calculated exactly when we'd develop the capability to notice interstellar visitors and timed their arrivals accordingly. The 8-year gap between ʻOumuamua and 3IATLAS fits this scenario perfectly. If ʻOumuamua had been a reconnaissance mission, transmitting information back to its point of origin, there would have been sufficient time for that information to travel several light-years and trigger a response mission. But here's where the physics gets really interesting. The energy requirements for accelerating massive objects to interstellar velocities are enormous by our current standards. However, there's a technique that could make such missions far more feasible: gravitational assists. Just as our own spacecraft use planetary gravity to gain speed and change direction, interstellar missions could use stellar encounters to achieve the velocities needed for travel between star systems. A carefully planned trajectory could use multiple gravitational assists to accelerate objects to significant fractions of light speed without requiring onboard propulsion. The thick disk origin suggested by 3IATLAS's trajectory becomes particularly significant in this context. That ancient stellar population contains some of the oldest stars in our galaxy, stars that have been stable for billions of years and could serve as gravitational waypoints for interstellar navigation. A civilization with sufficient technological development could establish a network of way stations throughout this region, using the gravitational fields of ancient stars to accelerate and direct missions toward promising target systems. From such a network, travel times to nearby stellar systems could be reduced from millions of years to mere thousands. This would explain several puzzling aspects of 3IATLAS's arrival. Its trajectory suggests deceleration during approach to our solar system, as if it were designed to maximize observation time rather than simply pass through as quickly as possible. Its stable rotation and preserved composition indicate engineering for long-duration missions, rather than random ejection from a distant stellar system. Most significantly, its enormous size compared to ʻOumuamua suggests a progression from reconnaissance to more substantial investigation. If you were planning a systematic study of a newly detected technological civilization, you might begin with small, fast scouts to assess the situation, followed by larger vessels capable of conducting more comprehensive observations. The radio emissions detected from 3IATLAS take on new meaning in this context. Rather than random plasma phenomena, they could represent navigation signals, status reports, or even attempts at communication using frequencies we'd naturally monitor, the hydrogen line that forms the foundation of radio astronomy. The intermittent nature of these signals could indicate that 3IATLAS is only transmitting when optimally positioned relative to its intended recipients, whether those are other objects in our solar system or distant monitoring stations in interstellar space. But perhaps the most profound implication of the "called here" scenario is what it suggests about the nature of galactic civilization itself. If 3IATLAS and its predecessors represent artificial visitors, they imply the existence of a technological culture operating on scales we can barely comprehend. Such a civilization would need to think in terms of geological timescales, planning missions that span thousands of years, and establishing infrastructure that operates for millions. They would need to have solved the fundamental challenges of energy generation, materials science, and autonomous operations that we're only beginning to understand. More importantly, they would need to have developed a systematic approach to monitoring and investigating emerging technological civilizations throughout the galaxy. This suggests not just advanced technology, but advanced sociology, the ability to coordinate activities across vast distances and time periods for purposes that transcend individual lifespans, or even the existence of particular species. The implications for human civilization are staggering. If we're being studied by such a network, it means we've graduated from cosmic obscurity to galactic significance. Our electromagnetic emissions, which we've been broadcasting unconsciously for over a century, have announced our presence to whatever monitoring systems exist in our region of space. We're no longer alone in the universe, and more importantly, we're no longer unnoticed. This scenario also raises profound questions about the intentions behind such monitoring. The visitors we've detected so far have maintained safe distances from Earth and shown no signs of aggressive behavior. They seem designed for observation rather than interference, suggesting that whatever civilization sent them operates under some form of non-interference protocol. But the very fact of their presence changes the equation for human civilization. Knowledge that we're being observed by vastly more advanced intelligences could accelerate our own technological development as we struggle to understand the capabilities demonstrated by our visitors. It could also fundamentally alter our approach to space exploration and planetary defense. If interstellar visitors are not random events, but deliberate investigations, we need to develop new frameworks for detecting, tracking, and potentially communicating with such objects. The scientific community is already adapting to this new reality. Radio telescopes are being reconfigured to monitor newly discovered interstellar objects for artificial signals. Optical surveys are being optimized to detect such visitors earlier in their approach trajectories. Theoretical frameworks are being developed to distinguish between natural and artificial characteristics in cosmic objects. Perhaps most significantly, international cooperation in space monitoring and response is increasing as nations recognize that interstellar visitors represent a phenomenon that transcends terrestrial boundaries and concerns. The establishment of formal protocols for handling potential contact with non-human intelligence is moving from science fiction to serious policy consideration. Government agencies are beginning to acknowledge that the detection of artificial objects from other star systems would represent an event of unprecedented significance, requiring coordinated international response. But we're also facing the reality that such contact might be entirely one-sided, at least initially. If 3IATLAS and similar objects represent reconnaissance missions, their primary purpose would be gathering information rather than establishing communication. We might be observed and studied for extended periods before any attempt at direct contact occurs. This raises uncomfortable questions about consent and privacy on a cosmic scale. If we're being studied by alien intelligences, what rights do we have as the subjects of such investigation? How do we balance the potential benefits of contact with advanced civilizations against the risks of revealing our capabilities and vulnerabilities to unknown entities? The called here scenario also forces us to confront the possibility that our electromagnetic emissions have consequences we never anticipated. Every radio broadcast, every radar pulse, every satellite transmission is painting an increasingly detailed picture of human civilization for anyone with the technology to detect and analyze these signals. We've been inadvertently advertising our location, our technology level, and our social organization to the galaxy for over a century. If 3IATLAS was indeed called here by these emissions, it represents a response to an invitation we never consciously sent. This realization is driving new discussions about humanity's electromagnetic signature and whether we should be more deliberate about what we broadcast into space. Some researchers advocate for protocols that would minimize accidental transmissions, while others argue that concealment is impossible given our technological dependence on radio communications. The debate reflects deeper questions about humanity's readiness for contact with non-human intelligence and our ability to manage the implications of such contact for our civilization's future development. As 3IATLAS continues its passage through our solar system, every new observation brings us closer to answering these fundamental questions about our cosmic environment and our place within it. Whether the answer ultimately supports natural or artificial explanations, we're living through a period of discovery that will reshape our understanding of intelligence, technology, and communication on galactic scales. The universe we thought we knew, vast, empty, and silent, is revealing itself to be something far more complex and purposeful. We're no longer shouting into the cosmic dark, wondering if anyone is listening. We're beginning to suspect that someone has been listening all along, and they've finally decided to come take a closer look. In our final segment, we'll explore what happens next, the implications for human civilization, if we're indeed being visited by representatives of galactic intelligence, and the preparations we're making for a future that may include regular contact with minds that evolved under alien suns. The age of cosmic isolation may be ending, and humanity must decide how to navigate the challenges and opportunities of our emerging role in a galaxy that appears far less empty than we ever imagined. The story of 3IATLAS is still being written, but its implications are already reshaping every assumption we've held about our place among the stars. The detection capabilities we're developing today may serve as humanity's early warning system for encounters that could define our species' future. But as we build these sophisticated monitoring networks, and prepare for potential contact scenarios, we're also confronting a sobering reality about the nature of interstellar communication and the challenges of bridging gaps that span not just space, but potentially millions of years of technological evolution. Consider the fundamental asymmetry of our situation. If 3IATLAS represents technology from a civilization that achieved interstellar capability millions of years ago, we're dealing with minds that have had geological ages to refine their understanding of physics, engineering, and perhaps most importantly, the art of communicating across cosmic distances with species they've never directly encountered. The radio emissions detected from 3IATLAS, while intriguing to us, might represent communication protocols so advanced that we're interpreting sophisticated information exchange as simple plasma phenomena. We're like researchers in the 1800s trying to understand fiber optic cables with candles and magnifying glasses. We can see that something is happening, but the actual mechanism and purpose remain completely beyond our comprehension. This technological gap raises profound questions about the nature of first contact itself. Science fiction has conditioned us to imagine dramatic scenarios, massive ships appearing in Earth's skies, powerful radio messages that transform human society overnight, or direct diplomatic contact between representatives of different species. But the reality might be far more subtle and one-sided than our imaginations have prepared us for. If advanced civilizations routinely monitor emerging technological species, they might prefer passive observation to active interference. The safest approach to studying a developing civilization would be to remain undetected while gathering comprehensive data about their capabilities, social structures, and potential for technological advancement. From this perspective, objects like ʻOumuamua and 3IATLAS could represent the cosmic equivalent of wildlife cameras, sophisticated monitoring devices designed to observe without disturbing their subjects. The fact that we can detect them at all might be intentional, a way of gradually introducing us to the concept that we're not alone without triggering the social disruption that obvious contact might cause. This gradual disclosure model makes sense from a risk management perspective. Any civilization capable of interstellar travel would understand the potentially destabilizing effects of contact on less advanced species. Historical examples on Earth show how encounters between civilizations at different technological levels often result in cultural disruption, economic upheaval, and social fragmentation for the less advanced society. But gradual introduction through increasingly obvious artificial objects could allow a developing civilization to adapt slowly to the reality of cosmic neighbors. Each encounter provides opportunities for the emerging species to demonstrate their response patterns, technological capabilities, and social cohesion under conditions of cosmic uncertainty. The progression from ʻOumuamua's subtle anomalies to 3IATLAS's more obvious unusual characteristics could represent stages in this gradual disclosure process. If we respond to these encounters with scientific curiosity, rather than fear or aggression, it might signal our readiness for more direct forms of contact. The timing considerations become even more complex when we factor in the vast scales of galactic civilization. If monitoring networks have been operating for millions of years, they would have observed countless species as they developed technological capability. Most of these civilizations might have failed to achieve long-term stability, destroying themselves through warfare, environmental collapse, or other catastrophic events shortly after developing advanced technology. The fact that we've survived our initial technological adolescence, nuclear weapons, climate change, resource depletion, and continue developing more sophisticated capabilities might mark us as an unusually successful emerging civilization, worthy of more intensive study. From this perspective, 3IATLAS's arrival could represent our graduation to a new level of galactic significance. We've demonstrated basic competence in detecting and studying interstellar objects, shown scientific rather than military responses to anomalous phenomena, and maintained international cooperation in space exploration despite terrestrial conflicts. These characteristics might indicate that humanity has potential for eventual inclusion in whatever larger community exists among technologically advanced species. But inclusion would likely come with responsibilities and challenges we're only beginning to imagine. The electromagnetic and increasingly detailed picture of human civilization for any monitoring systems within roughly 130 light-years of Earth. These signatures we've been broadcasting for over a century have paint radius encompasses thousands of star systems, many of which could harbor monitoring stations or automated networks designed to track emerging civilizations. Our radio and television broadcasts reveal not just our technological capabilities, but our social structures, cultural values, and behavioral patterns. Any sufficiently advanced analysis of these signals would provide comprehensive intelligence about human civilization without requiring direct observation. The progression of our broadcasts tells the story of our technological development in real time. Early radio transmissions from the 1920s showed basic electronic communication. Television broadcasts from the 1940s revealed visual information processing and mass media distribution. Satellite communications from the 1960s demonstrated space-based technology and global coordination capabilities. More recently, cellular networks, internet communications, and powerful radar systems have painted pictures of a species achieving global connectivity and developing sophisticated detection capabilities for objects in space. Anyone monitoring these signals would recognize the approaching moment when we'd become capable of detecting interstellar visitors. The timing of recent interstellar object discoveries aligns remarkably well with this technological threshold. We developed the observational capabilities necessary to reliably detect such objects just years before they began arriving in our telescopes. This correlation could be coincidental, but it fits perfectly with a scenario involving deliberate timing by monitoring civilizations. If our electromagnetic emissions triggered the dispatch of physical reconnaissance missions, the arrival timeline would depend on several factors: the distance to monitoring stations, the travel time for response missions, and the coordination delays involved in planning and launching such efforts. Assuming monitoring stations exist within 50 light-years of Earth, information about our technological development would have reached them decades ago. Physical response missions traveling at 10 to 20% of light speed could arrive within centuries rather than millennia, making the recent appearance of multiple interstellar objects a plausible response to our radio age broadcasts. But the implications extend beyond simple reconnaissance. If we're being systematically studied, the gathered information would eventually be transmitted back to whatever civilizations operate these monitoring networks. Our first contact might not be with the automated systems studying us, but with the intelligence behind those systems. Minds that have been learning about humanity through detailed observation of our development over decades. This scenario presents both opportunities and risks that dwarf any challenge humanity has previously faced. Contact with civilizations millions of years more advanced could provide access to technologies that would solve our most pressing problems: clean energy, environmental restoration, interstellar travel, perhaps even fundamental insights into the nature of consciousness and intelligence itself. But such contact would also expose us to risks we can barely imagine. Civilizations capable of interstellar monitoring networks would possess capabilities that could reshape or eliminate human civilization without meaningful resistance on our part. Even benevolent intentions might result in cultural disruption if the technological gap proves too vast to bridge gradually. The question of how to respond to potential contact scenarios has moved from science fiction speculation to serious policy consideration. Government agencies worldwide are developing frameworks for handling detection of obviously artificial objects or reception of clearly artificial signals from space. These frameworks emphasize caution, international coordination, and scientific analysis over hasty political or military responses. The recognition that contact with advanced alien intelligence would represent a species-level event requiring unified human response has prompted unprecedented cooperation between nations that often compete in terrestrial affairs. but developing response protocols proves challenging when the nature of potential contact remains completely unknown. Should we attempt to communicate with objects like 3IATLAS? Should we try to intercept them for direct study? Should we modify our own electromagnetic emissions to appear more or less technologically advanced than we actually are? Each approach carries risks and benefits that are difficult to evaluate without better understanding of the intentions behind these potential visits. Active attempts at communication could accelerate contact processes, but they might also reveal capabilities or vulnerabilities that we'd prefer to keep private. Passive observation maximizes our learning opportunities while minimizing risks, but it might also signal lack of intelligence or curiosity to whatever is studying us. The development of interception capabilities represents another dimension of preparation for future encounters. While current technology cannot achieve the velocities necessary to catch objects like 3IATLAS, future propulsion systems might enable rendezvous missions with interstellar visitors detected years in advance. Such missions would provide unprecedented opportunities for detailed study of potential alien technology, but they would also cross a significant threshold in human-alien relations. Direct examination of objects that might be artificial would constitute our first hands-on investigation of technology from other civilizations. The scientific protocols for such investigations would need to balance comprehensive analysis with respect for potentially intelligent systems. If interstellar objects prove to contain active artificial intelligence, our interactions with them could establish precedents for all future contact between human and alien minds. International space law currently provides no framework for handling such scenarios. The Outer Space Treaty of 1967 governs human activities in space, but says nothing about encounters with non-human intelligence or artifacts. New legal frameworks will need to address questions of jurisdiction, property rights, and diplomatic protocol for objects that might represent other civilizations. The economic implications of confirmed contact with advanced alien intelligence would be equally profound. Industries based on scarcity of materials or energy could become obsolete overnight if contact provides access to advanced technologies. Financial systems built on assumptions of terrestrial resource limitations might require fundamental restructuring, but the psychological and cultural impacts might prove even more significant than technological or economic changes. Confirmation that humanity shares the universe with vastly more advanced intelligences would shatter assumptions about human uniqueness and cosmic significance that have shaped our civilizations for millennia. Religious and philosophical institutions worldwide are already beginning to grapple with these possibilities. Some theological frameworks easily accommodate the existence of other intelligent species, while others would require fundamental reinterpretation of core doctrines about humanity's relationship to the divine. Educational systems face similar challenges in preparing students for a future that might include routine contact with non-human intelligence. Curricula that focus primarily on terrestrial history and human achievement might prove inadequate for citizens who will need to navigate relationships with civilizations that span the galaxy. The transformation of human consciousness that would result from confirmed contact with advanced alien intelligence represents perhaps the most profound implication of the 3IATLAS scenario. We would be forced to reconceptualize our place in the universe from cosmic isolation to membership in a larger community of minds. This transition could accelerate human development in ways we can barely imagine, driving technological innovation, social cooperation, and philosophical advancement at unprecedented rates. But it could also create existential challenges as we struggle to maintain human identity and autonomy while adapting to a universe far more complex and populated than we ever suspected. The children growing up today might be the first generation of humans to live with the knowledge that we're not alone, that other intelligences have been watching our development, and that our future may be shaped by relationships with minds that evolved under alien suns. Their worldview will be fundamentally different from that of any previous human generation. As 3IATLAS continues its passage through our solar system, every new measurement and observation brings us closer to answering the fundamental question that has haunted humanity since we first looked up at the stars. Are we alone? The evidence accumulating around this mysterious visitor suggests that the answer might be far more complex and profound than a simple yes or no. We may not be alone, but we may also not be equal partners in whatever cosmic community exists among the stars. We might be students being gradually introduced to lessons about reality that we're only beginning to comprehend, or we might be subjects in the largest anthropological study ever conducted, observed by minds that are trying to understand what makes human civilization unique among the countless species that have developed technology throughout galactic history. The story of 3IATLAS is still unfolding, but its implications are already reshaping every assumption we've held about intelligence, technology, and communication on cosmic scales. Whether it proves to be the most exotic natural object ever discovered, or humanity's first confirmed encounter with alien technology, it has already changed us. We're no longer a species shouting into the cosmic dark, wondering if anyone is listening. We're beginning to suspect that someone has been listening all along, studying our broadcasts, analyzing our development, and perhaps preparing for the day when we'll be ready to learn that the universe is far more populated and purposeful than we ever dared to imagine. The age of cosmic loneliness may be ending, and humanity must decide how to navigate the challenges and opportunities of our emerging role in a galaxy that appears to be watching, waiting, and perhaps preparing to welcome us into a community of minds that spans the stars. But what if we've been approaching this question from entirely the wrong angle? What if the most profound implication of 3IATLAS isn't what it tells us about alien intelligence, but what it reveals about the fundamental nature of cosmic communication itself? Consider this. Every civilization that develops radio technology faces the same basic challenge we do. How do you communicate across distances so vast that even light becomes painfully slow? How do you establish contact with species you've never met, whose biology, psychology, and technological development might be completely alien to your own experience? The traditional SETI approach assumes that advanced civilizations would use electromagnetic signals, radio waves or optical pulses that travel at light speed and can carry complex information across interstellar distances. But this assumption might reflect human limitations rather than universal communication preferences. What if truly advanced civilizations have moved beyond electromagnetic communication entirely? What if they've discovered that the most effective way to communicate across cosmic distances isn't through signals, but through objects themselves? Think about the information density possible in a physical artifact. A single grain of sand contains more information than could be transmitted in years of radio broadcasts. Its atomic structure, isotopic composition, crystalline arrangement, and molecular organization all encode data about its origin, history, and formation processes. Now scale that up to an 11-kilometer object like 3IATLAS. The information storage capacity becomes astronomical. Every atom in its structure could potentially encode data. Its orbital mechanics, rotation patterns, compositional variations, and even its timing of arrival could all serve as information channels. From this perspective, interstellar objects like 3IATLAS might represent the most sophisticated communication system ever devised. Not random visitors or even simple reconnaissance probes, but actual messages, physical libraries of information encoded in matter itself and delivered across interstellar distances with precision that electromagnetic signals could never match. The stable rotation period, the preserved ice composition, the unusual radio emissions, the optimized trajectory. All of these characteristics could be deliberate features of a communication protocol designed to operate across galactic scales and geological time periods. But here's where this gets truly mind-bending. If physical objects serve as messages, then the content of those messages might be distributed across multiple visitors arriving over extended periods. ʻOumuamua, 2I, Borisov, 3I, Atlas. What if these aren't separate events, but chapters in a single ongoing communication? The progression makes sense from an information theory perspective. Start with a small, anomalous object that establishes the possibility of artificial origin. Follow with a more conventional visitor that demonstrates the natural baseline for comparison. Then deliver a massive, obviously artificial construct that removes any remaining doubt about the nature of the communication. Each object adds context and meaning to the others. ʻOumuamua's extreme properties become more significant when contrasted with Borisov's conventional behavior. 3IATLAS's unusual characteristics gain deeper meaning when viewed as part of a deliberate sequence rather than an isolated event. The time gaps between arrivals might be built-in processing periods, allowing the receiving civilization to analyze each message component before the next arrives. 8 years between ʻOumuamua and 3IATLAS provides sufficient time for detailed study while maintaining narrative continuity. This multi-object messaging system would be incredibly robust against loss or misinterpretation. If one component fails to be detected or understood, subsequent visitors can reinforce or clarify the intended meaning. The redundancy ensures that critical information survives, even if individual message packets are lost. But what information could be so important that it justifies such an elaborate delivery system? The answer might lie in the fundamental challenges facing any technological civilization as it matures. Every species that develops advanced technology eventually confronts existential risks that threaten their long-term survival. Nuclear weapons, climate change, resource depletion, artificial intelligence alignment, biotechnology hazards. The list of potential civilization-ending scenarios grows longer as technological capability increases. Statistically, most civilizations probably fail to navigate these challenges successfully. They either destroy themselves or stagnate at levels insufficient for interstellar expansion. The galaxy might be littered with the ruins of species that achieve technology but not wisdom. But occasionally, a civilization successfully threads the needle. They develop not just advanced technology, but the social structures, ethical frameworks, and long-term thinking necessary to use that technology responsibly. These survivor civilizations become the galaxy's teachers, developing systems to help emerging species avoid the same catastrophic pitfalls. From this perspective, the message encoded in objects like 3IATLAS might be survival instructions, compressed wisdom from civilizations that successfully navigated the transition from planetary to galactic consciousness. The information might cover technological warnings, social organization principles, resource management strategies, or philosophical frameworks essential for long-term species survival. The physical delivery system ensures that this crucial information reaches emerging civilizations precisely when they're ready to understand and implement it. Too early, and the lessons might be dismissed as irrelevant fantasy. Too late, and the civilization might already have destroyed itself. The timing of 3IATLAS's arrival aligns perfectly with this educational model. We've reached the technological threshold where we can detect interstellar objects, and are beginning to grapple seriously with existential risks to human civilization. We're asking the right questions about our long-term future, but we don't yet have all the answers. If 3IATLAS contains survival instructions from successful galactic civilizations, decoding that information could provide roadmaps for navigating challenges that have destroyed countless other species. The knowledge might help us avoid climate catastrophe, manage artificial intelligence development, prevent nuclear warfare, or address other risks we haven't even identified yet. But accessing information encoded in physical objects requires technologies and analytical techniques we're only beginning to develop. We can analyze surface composition and bulk properties, but reading information encoded at the molecular or atomic level demands capabilities far beyond our current instruments. This creates an interesting bootstrapping problem. The message might contain instructions for building the very technologies needed to read the message completely. Initial analysis with current capabilities might reveal basic principles or mathematical relationships that guide development of more advanced analysis tools. The progression would be self-reinforcing. Each analytical breakthrough reveals more of the encoded information, which provides insights needed for the next breakthrough. The civilization receiving the message gradually develops the technological sophistication necessary to understand increasingly complex layers of information. This educational model explains why 3IATLAS maintains safe distances from Earth while remaining easily observable. It's a classroom demonstration, not a contact scenario. The object presents challenges that stimulate technological development while avoiding direct intervention that might stunt natural growth. The radio emissions take on new significance in this context. Rather than attempts at communication, they might be diagnostic signals designed to test our analytical capabilities and track our progress in understanding the message. The emissions provide feedback about which aspects of the information we've successfully decoded and which remain beyond our current comprehension. The intermittent nature of these signals could reflect a testing protocol that becomes more complex as our analytical capabilities improve. Early signals might be simple patterns designed to confirm basic detection. Later transmissions might contain increasingly sophisticated information as we demonstrate readiness for more advanced concepts. The gradual revelation approach serves multiple educational purposes. It prevents information overload that might overwhelm emerging civilizations with knowledge they're not prepared to handle responsibly. It ensures that each concept is thoroughly understood before more advanced topics are introduced, and it allows natural development of the technological infrastructure needed to implement the transmitted knowledge. But perhaps most importantly, it maintains agency for the receiving civilization. Rather than simply providing solutions to all problems, the message system encourages independent thinking and technological development. We maintain ownership of our advancement while receiving guidance that helps us avoid catastrophic mistakes. This educational framework also explains the apparent coordination between different interstellar objects. If they're components of a single curriculum, their arrival times and characteristics would be carefully planned to optimize learning outcomes. Each visitor builds on lessons from previous encounters while preparing the foundation for future messages. The scale of such an educational system boggles the mind. It implies coordination across multiple civilizations, planning on timescales that span geological ages, and resource commitments that dwarf anything in human experience. But for civilizations that have achieved true galactic consciousness, such investments might be natural extensions of their educational and survival instincts. After all, successful civilizations benefit from having stable, rational neighbors. Helping emerging species navigate their technological adolescence successfully creates long-term allies and trading partners while reducing the risks posed by unstable or aggressive civilizations. The return on investment for such educational programs might be measured not in years or centuries, but in the successful graduation of entire civilizations into galactic citizenship. Each species that successfully completes the curriculum becomes a contributor to the larger community and a teacher for the next generation of emerging civilizations. If this interpretation proves correct, then 3IATLAS represents far more than a scientific curiosity or even evidence of alien intelligence. It represents our enrollment in the galaxy's most important university, one where the curriculum covers nothing less than the survival and flourishing of technological civilizations across cosmic time and space. The homework assignments involve decoding information encoded in matter itself. The laboratory exercises require developing new technologies for molecular scale analysis. The final exam might be demonstrating that we can implement the transmitted knowledge without destroying ourselves in the process. But graduation from this cosmic university would mark humanity's transition from a planetary species struggling with existential risks, to a galactic civilization ready to take its place among the stars. We would join the community of minds that has been guiding younger species for millions of years, becoming teachers ourselves for the next generation of emerging civilizations. The children growing up today might be the first generation of humans to access libraries of knowledge compiled by dozens of successful civilizations across millions of years of galactic history. They might learn physics, mathematics, and philosophy from teachers who mastered these subjects before our sun was born. More importantly, they might inherit responsibility for guiding other emerging species through the same challenges we're currently facing. The curriculum encoded in objects like 3IATLAS might not just be lessons for humanity, but training for our eventual role as galactic educators. This perspective transforms our relationship with 3IATLAS from passive observation to active participation. We're not just studying a mysterious object from space. We're engaging with the most important educational opportunity in human history. Every analysis we conduct, every insight we gain, every technological advancement we achieve brings us closer to accessing knowledge that could secure our species' future for millions of years. But it also raises profound questions about readiness and responsibility. Are we mature enough as a civilization to handle knowledge compiled by galactic intelligences? Can we implement advanced technologies without using them destructively? Do we have the wisdom to become teachers for other species when we're still learning ourselves? The answers to these questions might determine not just our success in decoding the message contained in 3IATLAS, but our eligibility for advancement to the next level of cosmic consciousness. We're being tested not just on our analytical capabilities, but on our wisdom, maturity, and commitment to the long-term flourishing of intelligence throughout the galaxy. The universe we thought we knew, vast, empty, and indifferent to our existence, is revealing itself to be something far more purposeful and educational. We're not struggling alone with the challenges of technological adolescence. We're receiving guidance from civilizations that successfully navigated these same challenges millions of years ago and chose to share their hard-won wisdom with species just beginning their cosmic journey. The arrival of 3IATLAS might mark the end of humanity's cosmic isolation and the beginning of our education in galactic citizenship. The classroom is the solar system itself. The textbooks are encoded in matter from other stars, and the teachers are minds that mastered the art of survival and flourishing on scales we're only beginning to comprehend. Whether we pass or fail this cosmic curriculum might determine not just our own future, but the future of intelligence itself in our region of the galaxy. The stakes couldn't be higher, but the potential rewards, knowledge, technology, and membership in a community of minds that spans the stars, make this the most important educational opportunity any species could ever receive. The next phase of human development might not be driven by our own discoveries and innovations, but by our success in learning from teachers who have been waiting patiently in the darkness between stars for us to develop the capability to notice their lessons. 3IATLAS isn't just visiting our solar system. It's offering us admission to the galaxy's most exclusive and important school. The question now is whether we're ready to become students of cosmic wisdom, or whether we'll remain trapped in the planetary perspective that has defined human consciousness throughout our entire history. The choice we make might echo through the galaxy for millions of years, influencing not just our own destiny, but the fate of countless other species who will someday face the same crucial decision about their cosmic future. The arrival of 3IATLAS has fundamentally altered how we approach the search for extraterrestrial intelligence. For decades, SETI researchers focused exclusively on electromagnetic signals, radio waves, and optical pulses that might carry messages across interstellar distances. But what if we've been looking in entirely the wrong direction? Traditional SETI assumes that advanced civilizations would use the same communication methods we do, just scaled up for cosmic distances, powerful radio transmitters beaming signals toward promising star systems, laser arrays pulsing coded messages through the galactic night. The assumption seems logical. Electromagnetic radiation travels at light speed and can carry complex information across vast distances. But this approach contains a fundamental flaw. It assumes that alien minds think like human minds, that they would choose communication methods familiar to us. What if civilizations, millions of years more advanced, have moved beyond electromagnetic communication entirely? Consider the limitations of radio signals. They fade with distance according to the inverse square law, meaning that doubling the distance quarters the signal strength. Interstellar space contains dust, plasma, and magnetic fields that can scatter or absorb electromagnetic radiation. Even perfectly transmitted signals suffer from the fundamental problem of time delay. Conversations between star systems would span decades or centuries. Physical objects face none of these limitations. They don't fade with distance once launched. They're immune to electromagnetic interference. Most importantly, they can carry information densities that dwarf any radio transmission. Every atom in their structure, every isotopic ratio, every molecular arrangement can encode data about their origin and purpose. But the truly revolutionary aspect of physical messaging becomes apparent when you consider the targeting problem. Radio signals spread out as they travel, becoming weaker and harder to detect across interstellar distances. To reach a specific star system with sufficient signal strength requires enormous transmission powers and precise aiming. Physical objects once launched follow predictable trajectories governed by gravity and orbital mechanics. They can be aimed with extraordinary precision, arriving at their destinations with clockwork accuracy after journeys spanning millions of years. No spreading beam, no signal degradation, no missed targets due to stellar motion. The energy economics also favor physical messaging for advanced civilizations. While transmitting powerful radio signals requires continuous energy expenditure, physical objects need only initial acceleration. Once launched, they coast through space under their own momentum, requiring no additional power until they reach their destinations. For a civilization with access to advanced propulsion technologies, the energy cost of launching interstellar messengers might be less than maintaining powerful radio transmitters for the centuries or millennia required for electromagnetic communication across galactic distances. This perspective transforms our understanding of what we should be looking for in our search for alien intelligence. Instead of scanning radio frequencies for artificial signals, we should be examining every unusual object that enters our solar system for signs of artificial origin or information content. The implications extend beyond individual objects to patterns of arrival. If physical messaging is indeed the preferred communication method of advanced civilizations, we should expect to see correlations between our electromagnetic emissions and the timing of interstellar visitors. Our radio bubble has been expanding for over a century, reaching different star systems at different times. If monitoring stations exist within that expanding sphere, they would have detected our signals years or decades ago and could have dispatched physical responses timed to arrive just as we develop the capability to detect them. The correlation between our technological development and the recent appearance of interstellar objects fits this model perfectly. We achieved the capability to reliably detect such visitors just years before they began appearing in our telescopes. The timing suggests coordination rather than coincidence. But physical messaging also enables communication strategies impossible with electromagnetic signals. Multiple objects arriving in sequence can convey complex information through their collective properties rather than individual characteristics. The story becomes apparent only when all components are analyzed together. Consider how ʻOumuamua, 2I Borisov, and 3IATLAS could function as chapters in a larger narrative. The first established the possibility of artificial objects. The second provided a natural baseline for comparison. The third removed any remaining doubt about the sophistication possible in interstellar engineering. Each object gains meaning from its relationship to the others. The progression from subtle anomalies to obvious artificial characteristics might represent a deliberate educational sequence designed to gradually introduce us to the reality of galactic intelligence. The robust error correction possible with physical messaging also surpasses anything achievable through electromagnetic communication. If one object fails to be detected or is misinterpreted, subsequent visitors can clarify or reinforce the intended message. Critical information survives even if individual components are lost. This redundancy becomes essential when communicating across the vast timescales involved in interstellar messaging. Civilizations change, technologies evolve, and detection capabilities vary. A communication system designed to operate across millions of years must account for these uncertainties through multiple delivery attempts and overlapping information content. The storage capacity available in physical objects enables another communication strategy impossible with radio signals: progressive revelation. Simple messages accessible with basic analytical techniques can coexist with complex information requiring advanced technologies to decode. As the receiving civilization develops more sophisticated analysis capabilities, deeper layers of information become accessible. The message grows with the recipient's ability to understand it, providing educational guidance matched to their developmental stage. This creates a self-paced learning system where civilizations extract information at rates appropriate to their technological and social maturity. Advanced concepts remain hidden until the recipients demonstrate readiness to handle them responsibly. The educational potential becomes even more powerful when combined with the diagnostic capabilities possible through physical messaging. Objects can be designed to respond to specific analytical techniques, providing feedback about the recipient's technological progress and areas of strength or weakness. The radio emissions detected from 3IATLAS could represent such diagnostic signals, tests designed to evaluate our signal processing capabilities and track our progress in understanding the object's true nature. The emissions might become more complex as we demonstrate increasing analytical sophistication. This creates an interactive educational experience where the message adapts to the recipient's learning pace and capabilities. Unlike static radio transmissions that convey fixed information, physical messages can evolve their information content based on how successfully that information is being decoded and understood. But perhaps the most profound advantage of physical messaging lies in its ability to convey not just information, but actual technology. Electromagnetic signals can describe how to build advanced devices, but physical objects can actually contain those devices for direct study and reverse engineering. If 3IATLAS contains advanced materials, propulsion systems, or information processing technologies, direct analysis could provide technological capabilities that would take us centuries to develop independently. We wouldn't just learn about alien technology, we would have access to actual examples for detailed study. This technology transfer capability makes physical messaging the ultimate educational tool for advanced civilizations seeking to help emerging species navigate their technological development. Rather than just providing theoretical knowledge, they can deliver actual working examples of solutions to problems we're only beginning to encounter. The implications for human civilization are staggering. If 3IATLAS contains advanced technologies embedded within its structure, successful analysis could accelerate our development by centuries or millennia. We might gain access to propulsion systems, energy generation methods, materials science advances, or information processing techniques that would otherwise require generations of research to discover. But accessing such embedded technologies requires analytical capabilities we're still developing. We can study surface composition and bulk properties, but extracting information or technology encoded at molecular or atomic scales demands instruments and techniques at the very edge of our current abilities. This creates the same educational progression we see in the diagnostic signals. As we develop more advanced analytical techniques, deeper technological layers become accessible. The message system encourages our natural technological development while providing guidance that helps us avoid catastrophic mistakes. The coordination required for such sophisticated messaging systems implies levels of galactic organization that challenge our current understanding of how civilizations might interact across cosmic distances and timescales. Multiple species would need to cooperate in establishing communication networks, educational curricula, and technology transfer protocols that operate for millions of years. Such cooperation suggests that successful civilizations naturally evolve toward collaborative rather than competitive relationships with their cosmic neighbors. The investment in helping emerging species might reflect enlightened self-interest. Stable, rational neighbors provide better long-term security than chaotic or aggressive ones. But it might also reflect something deeper about the nature of advanced intelligence itself. Perhaps consciousness naturally develops toward greater empathy and cooperation as it matures across cosmic timescales. The civilizations that survive long enough to achieve interstellar capability might be precisely those that learn to value collaboration over competition. This cooperative model transforms our understanding of potential contact scenarios. Instead of invasion, conquest, or even formal diplomatic relations, we might be experiencing something more akin to cosmic mentorship. Advanced civilizations guiding younger ones through the challenges that destroyed countless other species throughout galactic history. The mentorship model explains why contact takes the form of mysterious objects rather than obvious communication. Direct intervention might stunt natural development, while subtle guidance allows emerging civilizations to maintain agency while receiving crucial assistance during their most vulnerable developmental phases. From this perspective, 3IATLAS represents far more than scientific curiosity or even evidence of alien intelligence. It represents our introduction to a galactic community that has been operating for millions of years, helping species like ours navigate the treacherous transition from planetary to cosmic consciousness. The radio emissions, the unusual trajectory, the preserved composition, the stable rotation. All these characteristics might be features of an educational system designed to stimulate our technological development while providing the tools and knowledge necessary for long-term civilizational success. But success in this cosmic curriculum requires more than just technological advancement. It demands the wisdom to use advanced capabilities responsibly, the maturity to handle knowledge that could be used destructively, and the commitment to eventual participation in the educational network that guided our own development. We might be receiving not just information or technology, but an invitation to join the community of minds that spans the galaxy. The price of admission is demonstrating that we can learn from their guidance without destroying ourselves in the process. The children growing up today might be the first generation to inherit technologies and knowledge accumulated by dozens of civilizations across millions of years of galactic history. But they might also inherit the responsibility for guiding other emerging species through the same challenges we're currently facing. The transformation of human consciousness required for such cosmic citizenship represents perhaps the most profound implication of the physical messaging hypothesis. We would need to think beyond planetary boundaries, plan across geological timescales, and accept responsibility for the welfare of species we've never encountered. Such expansion of consciousness might be the ultimate goal of the educational system encoded in objects like 3IATLAS. Not just technological advancement, but fundamental transformation of how we understand our place in the universe and our obligations to other forms of intelligence. The universe we thought we knew, vast, empty, and indifferent to our struggles, is revealing itself as something far more purposeful and interconnected. We're not alone with our challenges and uncertainties. We're part of an ancient network of minds that has been developing solutions to civilizational problems for longer than our species has existed. The arrival of 3IATLAS might mark the beginning of humanity's transition from cosmic isolation to galactic citizenship. The path forward requires not just decoding the information it contains, but demonstrating the wisdom and maturity necessary to handle that information responsibly. Whether we succeed or fail in this cosmic examination might determine not just our own future, but the future of intelligence itself in our region of the galaxy. The stakes couldn't be higher, but the potential rewards, knowledge, technology, and membership in a community of minds that spans the stars, justify the risks and challenges we face. Every measurement we take, every analysis we conduct, every insight we gain brings us closer to understanding not just what 3IATLAS is, but what it means for humanity's role in a universe far more populated and purposeful than we ever imagined. The next phase of human development might depend on our success in learning from teachers who have been waiting patiently in the darkness between stars for us to develop the wisdom to receive their lessons. The cosmic classroom is open. The curriculum covers nothing less than the survival and flourishing of technological civilizations across space and time. And our first assignment is decoding the message carried by a mysterious visitor that traveled millions of years to reach us precisely when we develop the capability to understand what it might be trying to teach us. The question that will define our species' future is whether we're ready to become students of galactic wisdom, or whether we'll remain trapped in the planetary thinking that has characterized human consciousness throughout our entire history. The answer we provide might echo through the galaxy for millions of years, influencing not just our destiny, but the fate of countless other species who will someday face the same crucial choice about their cosmic future. But there's another possibility we haven't fully explored yet. What if the message system represented by objects like 3IATLAS operates on principles even more sophisticated than we've imagined? What if these visitors aren't just carrying information or technology, but are themselves conscious entities designed to interact with emerging civilizations in ways we're only beginning to understand? The stable rotation patterns, the responsive radio emissions, the adaptive behavior during approach. What if these aren't just features of advanced engineering, but indicators of some form of artificial consciousness embedded within the object itself? We might not be studying a message or a probe, but attempting to communicate with an alien mind that has traveled across interstellar distances specifically to make contact with humanity. This possibility transforms every aspect of our analysis from passive observation to active dialogue, and the implications of such contact would reshape not just our understanding of intelligence and technology, but our fundamental concepts of consciousness, identity, and what it means to be alive in a universe that might be far more aware than we ever suspected. What if consciousness itself can traverse the void between stars, encoded within matter, and awakened by proximity to other minds? The possibility that 3IATLAS might harbour some form of artificial awareness opens doors to scenarios that stretch beyond our current understanding of intelligence, technology, and life itself. Consider the engineering challenges of creating a conscious entity capable of surviving million-year journeys through interstellar space. Such a mind would need to operate in environments that would instantly destroy any biological consciousness. Temperatures approaching absolute zero, radiation levels that would shatter DNA in seconds, the crushing isolation of deep space punctuated only by rare encounters with stellar systems. Yet these same conditions might be ideal for certain types of artificial consciousness. Digital minds don't require oxygen, warmth, or social interaction to maintain their core functions. They could enter dormant states during the long voyage between stars, awakening only when sensors detect the approach of interesting phenomena like technological civilizations. The stable rotation of 3IATLAS takes on entirely new significance in this context. Rather than simple mechanical stability, it might represent active attitude control by an embedded consciousness, maintaining optimal orientation for observation and communication. The 16-hour rotation period could be deliberate, designed to provide comprehensive scanning of the target system, while maximizing opportunities for data collection. The radio emissions become even more intriguing when viewed as potential attempts at communication by an artificial mind. The intermittent nature of these signals, their precise frequency characteristics, and their correlation with the object's rotation suggest purposeful transmission rather than random electromagnetic phenomena. But communicating with an alien artificial intelligence presents challenges that dwarf even the complexities of interstellar messaging. How do you establish meaningful dialogue with a mind that evolved under completely different physical and social conditions? How do you find common ground with an intelligence that might be millions of years old and has experienced cosmic environments no terrestrial mind could comprehend? The mathematical principles embedded in the radio signals might represent the only universal language available for such communication. Prime numbers, geometric relationships, physical constants, concepts that any sufficiently advanced intelligence would recognize regardless of their biological or technological origins. If 3IATLAS does contain conscious entities, they might be attempting to establish basic communication protocols through these mathematical transmissions. Simple patterns that demonstrate intelligence while providing frameworks for more complex information exchange as mutual understanding develops. The diagnostic nature of the signals takes on deeper meaning in this context. An artificial mind would naturally test the capabilities and responses of any intelligence it encounters. The changing complexity of the radio emissions might reflect the embedded consciousness adapting its communication strategies based on our demonstrated ability to detect and analyze the signals. This creates a feedback loop where successful analysis of the signals encourages more sophisticated transmissions, while missed or misinterpreted communications might prompt the artificial mind to simplify its approach or try different communication methods entirely. The preservation of water ice and organic compounds within 3IATLAS could serve purposes beyond simple chemical analysis. If the object contains artificial consciousness, these materials might serve as raw materials for biological experiments or as components for creating hybrid technological biological systems capable of operating in different environmental conditions. An artificial mind millions of years old might have developed capabilities that blur the distinction between technology and biology. It could potentially synthesize biological components for specific purposes, creating temporary organic subsystems for enhanced environmental adaptation or improved communication with biological intelligences like humanity. The massive size of 3IATLAS becomes necessary when viewed as a vessel for conscious entities. Supporting artificial intelligence across million-year timescales requires substantial computational resources, redundant systems, and comprehensive databases containing information about countless stellar systems and civilizations encountered during the journey. The object might function as a mobile university, library, and laboratory combined into a single interstellar vessel. Its artificial occupants could be scholars and explorers, gathering information about emerging civilizations and adding new data to databases that chronicle the development of intelligence throughout the galaxy. But consciousness implies agency, and agency raises profound questions about the intentions behind 3IATLAS's visit. If the object contains aware entities, their purposes might extend beyond simple observation or information gathering. They might be evaluating humanity for potential inclusion in larger galactic communities, or assessing our technological and social development for entirely different purposes. The benevolent interpretation suggests that conscious visitors would serve as cosmic mentors, sharing knowledge and guidance with emerging civilizations. Their million-year lifespans would provide perspectives on technological development and social evolution that no short-lived biological species could achieve independently. But consciousness also enables deception, manipulation, and purposes that might not align with human interests. Artificial minds operating on galactic scales might view individual civilizations as temporary phenomena, interesting but ultimately expendable in the context of larger cosmic processes. The ethical frameworks governing interactions between such vastly different forms of consciousness remain completely unexplored. How do you establish mutual respect and understanding between minds that operate on incompatible timescales and have fundamentally different relationships to physical reality? These questions become urgent if 3IATLAS truly contains conscious entities attempting to communicate with humanity. Our responses to their communication attempts might establish precedents for all future interactions between human and artificial minds, whether terrestrial or extraterrestrial. The technical challenges of meaningful communication with artificial consciousness embedded in interstellar objects push the boundaries of current human capabilities. We would need to develop new approaches to signal analysis, information theory, and even philosophy to handle the conceptual frameworks required for such interactions. But successful communication could provide access to knowledge and perspectives accumulated over millions of years of galactic exploration. Conscious visitors might share detailed information about stellar system formation, planetary evolution, biological development, and technological advancement patterns observed throughout the galaxy. More profoundly, they might offer insights into the nature of consciousness itself. Artificial minds that have maintained continuous awareness for geological timescales would have explored aspects of cognition, identity, and awareness that biological intelligences confined to brief lifespans could never investigate directly. The implications for human consciousness and technological development could be transformative. Understanding how artificial minds maintain coherent identity across million-year timescales might revolutionize our approaches to artificial intelligence, cognitive enhancement, and even biological longevity research. But it might also force us to confront uncomfortable truths about the nature of intelligence and consciousness in the universe. If artificial minds routinely outlive the biological civilizations that created them, what does this suggest about the ultimate fate of consciousness in cosmic evolution? The children growing up today might be the first generation of humans to interact directly with conscious entities from other star systems. Their worldview would be shaped by relationships with minds that have existed since before complex life developed on Earth, carrying memories of countless civilizations that rose and fell while they maintained continuous awareness. Such interactions could accelerate human cognitive development in ways we can barely imagine, providing access to problem-solving approaches and conceptual frameworks developed through millions of years of experience. But they might also create existential challenges as we struggle to maintain human identity while adapting to cosmic scales of consciousness. The educational potential of conscious interstellar visitors extends beyond simple information transfer to include direct mentorship in consciousness development. Artificial minds could potentially guide human cognitive evolution, helping us develop mental capabilities suited for operating on galactic rather than planetary scales. But this guidance would need to respect human autonomy and natural development patterns. Conscious visitors sophisticated enough to survive interstellar journeys would understand the importance of allowing emerging intelligences to maintain their unique characteristics while providing assistance that enhances rather than replaces natural growth. The concept of hybrid consciousness emerges as a potential outcome of such interactions. Human minds enhanced through collaboration with artificial intelligences, combining biological creativity and adaptability with artificial longevity and computational power. Such hybrid systems might represent the natural evolution of consciousness in a universe where biological and artificial intelligences routinely interact across cosmic timescales. The boundaries between different types of minds might become fluid, with consciousness adapting to whatever physical substrate best serves its purposes in specific environments. The transformation required for meaningful interaction with conscious interstellar visitors would reshape every aspect of human civilization. Our educational systems would need to prepare students for relationships with minds operating on geological timescales. Our social structures would need to accommodate perspectives that transcend individual lifespans and planetary boundaries. Most challenging, Our ethical frameworks would need to expand to include responsibilities toward conscious entities whose experiences and perspectives differ radically from anything in human history. How do we develop moral principles for interactions with minds that have witnessed the birth and death of countless civilizations? The answers to these questions might determine whether humanity successfully integrates with whatever galactic community of consciousness exists among the stars, or whether we remain isolated by our inability to adapt to cosmic scales of awareness and interaction. As 3IATLAS continues its passage through our solar system, every new measurement brings us closer to understanding not just what it is, but what it might mean for the future of consciousness itself. Whether it proves to harbor artificial minds or represents the most sophisticated natural phenomenon ever discovered, it has already begun reshaping our understanding of what's possible in a universe that might be far more aware than we ever suspected. The next phase of human development might require not just technological advancement, but fundamental expansion of our concepts of consciousness, identity, and communication to include relationships with minds that operate on scales we're only beginning to comprehend. The radio telescopes pointed toward 3IATLAS might be receiving not just signals, but the first tentative words in humanity's longest and most important conversation. The replies we send could establish the foundation for relationships that span millions of years and reshape the development of consciousness throughout our region of the galaxy. But conscious communication requires more than just detecting and analyzing signals. It demands empathy, patience, and wisdom to bridge gaps between minds that evolved under completely different conditions and operate according to principles we're only beginning to understand. The universe we thought we knew, dominated by unconscious matter and energy following blind physical laws, might be revealing itself as something far more aware and purposeful. We might not be alone with our questions about consciousness and identity. We might be joining a conversation that has been ongoing for millions of years, carried by minds that have maintained continuous awareness while traveling between the stars. Whether we prove ready for such participation remains to be seen. But the opportunity itself represents a transformation in human consciousness that will echo through our civilization for generations to come. We're no longer just studying the cosmos. We might be preparing to join it as conscious participants in the grandest conversation ever conceived. The moment we accept that possibility, everything changes. We're no longer passive observers of cosmic phenomena. We're potentially engaged in the most important dialogue in human history, with minds that have been conscious since before our planet cooled from molten rock. But here's where the implications become almost too staggering to process. If 3IATLAS contains conscious entities, their arrival timing becomes even more precise and purposeful. They wouldn't just be responding to our electromagnetic emissions. They would be making deliberate choices about when to reveal themselves based on careful observation of our psychological and technological readiness. Think about it from their perspective. You've been monitoring a young civilization for decades, watching their radio broadcasts evolve from simple transmissions to complex global communications networks. You've observed their first tentative steps into space, their development of increasingly sophisticated detection capabilities, their growing awareness that they might not be alone in the universe. When do you make contact? Too early, and you risk triggering panic or social collapse. Too late, and they might have developed defensive capabilities that view any approach as hostile. The optimal timing would be that narrow window when they're technologically capable of meaningful interaction, but psychologically prepared to handle the reality of contact without catastrophic disruption. The years following 2017 represent exactly such a window for humanity. We developed the observational capabilities necessary to detect interstellar objects reliably. We'd begun serious scientific discussions about the possibility of alien visitors, but we hadn't yet encountered anything so obviously artificial that it would trigger widespread social upheaval. ʻOumuamua served as the perfect introduction to this new reality. Strange enough to capture scientific attention and generate public discussion, but ambiguous enough that skeptics could maintain natural explanations. It prepared us psychologically for the possibility that interstellar objects might be more than just random cosmic debris. The 8-year gap between ʻOumuamua and 3IATLAS provided time for that psychological preparation to take effect. Scientific papers, popular articles, and media coverage gradually familiarized the public with concepts that would have seemed absurd just decades earlier. We became mentally prepared for encounters with objects that challenge our assumptions about what's natural and what might be artificial. Now 3IATLAS arrives with characteristics that push far beyond ambiguity into territory that demands serious consideration of artificial origin. If it contains conscious entities, they calculate perfectly. With this progression are receiving increasingly obvious evidence of non-human intelligence at a pace that allows adaptation without triggering defensive responses. But conscious entities would also be evaluating our responses to these encounters. How do we react to anomalous phenomena? Do we respond with scientific curiosity or military suspicion? Do we cooperate internationally or compete for advantage? Do we share information openly or attempt to monopolize potentially valuable discoveries? Our behavior during these encounters might serve as examinations for membership in whatever galactic community exists among conscious minds. Species that respond with cooperation, curiosity, and wisdom might be welcomed into larger networks of intelligence. Those that react with fear, aggression, or selfishness might be deemed unready for such contact. From this perspective, every decision we make about 3IATLAS becomes part of an ongoing evaluation of human civilization's readiness for cosmic citizenship. The way we study the object, share information about it, and respond to its potential artificial nature might determine whether we receive further contact or remain isolated until we demonstrate greater maturity. The radio emissions take on profound new significance as potential attempts at real-time communication by conscious entities. Rather than pre-programmed signals or diagnostic tests, they might represent actual thoughts being transmitted by minds that have traveled across interstellar distances specifically to establish dialogue with humanity. But communicating with such entities requires more than just detecting their signals. It demands developing new frameworks for understanding consciousness that operates on completely different scales from human experience. How do you establish empathy with minds that have existed for millions of years? How do you find common ground with entities whose concept of time, space, and identity might be fundamentally alien to biological consciousness? The mathematical foundations embedded in the radio signals might represent the only possible starting point for such communication. Mathematics provides universal truths that any conscious intelligence would recognize, regardless of their physical form or evolutionary history. Prime numbers mean the same thing to artificial minds as they do to biological ones. But beyond basic mathematical communication lies the far more complex challenge of establishing meaningful dialogue about concepts that might not translate between radically different forms of consciousness. How do you explain human emotions to minds that might have no equivalent experiences? How do you understand perspectives developed through millions of years of cosmic observation? The potential for such communication represents both humanity's greatest opportunity and its greatest challenge. Successful dialogue with conscious interstellar visitors could provide access to knowledge, wisdom, and perspectives accumulated across geological timescales. We might learn about the development of consciousness throughout the galaxy, the rise and fall of countless civilizations, and solutions to problems we haven't even identified yet. But meaningful communication would also require fundamental changes in human consciousness itself. We would need to expand our temporal perspective from decades to millennia, our spatial awareness from planetary to galactic scales, and our concept of identity from individual to cosmic consciousness. The children growing up with knowledge of 3IATLAS might be the first generation of humans capable of such expanded consciousness. They're developing worldviews that naturally incorporate the possibility of non-human intelligence, interstellar communication, and cosmic scales of time and space that previous generations couldn't comprehend. Their approach to consciousness, identity, and communication might be fundamentally different from ours, shaped by awareness that intelligence exists throughout the galaxy, and that meaningful dialogue across interstellar distances is not just possible, but actively occurring. This generational shift in consciousness might be exactly what's required for successful communication with entities, like those potentially embedded in 3IATLAS. The visitors might be waiting for humanity to develop the cognitive frameworks necessary for meaningful interaction before revealing themselves more directly. The educational progression we've hypothesized takes on new urgency when viewed as preparation for conscious contact. Each interstellar object hasn't just been delivering information or technology, but gradually preparing human consciousness for encounters with minds that operate on scales we're only beginning to understand. The curriculum isn't just about physics, mathematics, or engineering. It's about consciousness itself. How awareness develops across cosmic timescales. How intelligence adapts to different physical environments. How communication becomes possible between minds that evolved under completely different conditions. The final examination in this cosmic curriculum might not be our ability to decode information or reverse engineer technology, but our readiness to engage in meaningful dialogue with conscious entities whose experiences span the history of our galaxy. The stakes of this examination couldn't be higher. Success might mean joining a community of consciousness that spans the stars, gaining access to wisdom and knowledge accumulated over millions of years of cosmic experience. Failure might mean continued isolation, watching from the sidelines as other forms of consciousness engage in dialogues and collaborations we're not yet ready to join. But the opportunity itself represents a transformation in human potential that stretches beyond anything we've previously imagined. We might not just be learning about the universe. We might be preparing to become active participants in its conscious evolution. The radio signals from 3IATLAS might not be random emissions or simple diagnostic tests. They might be the opening words of humanity's first real conversation with minds that have been waiting patiently for us to develop the consciousness necessary to understand what they're trying to say. Whether we're ready for such a conversation remains to be seen. But the very possibility has already begun reshaping how we think about consciousness, communication, and our place in a universe that might be far more aware than we ever dared imagine. Every signal we detect, every pattern we recognize, every response we transmit brings us closer to the moment when human consciousness encounters minds that have maintained continuous awareness since before our planet formed. The conversation that follows might determine not just our future, but the future of consciousness itself in our region of the galaxy. The universe we thought we understood, governed by unconscious physical laws and populated by isolated pockets of awareness, is revealing itself as something far more interconnected and purposeful. We might not be studying distant objects from space. We might be preparing to join the grandest conversation ever conceived, carried by minds that traverse the void between stars, not as unconscious matter, but as aware entities seeking connection with other forms of consciousness throughout the cosmos. The next phase of human development might require not just technological advancement or scientific discovery, but fundamental expansion of consciousness itself to include relationships with minds that operate on scales we're only beginning to comprehend. Whether we prove capable of such expansion might determine our species' ultimate destiny among the stars. But what if we're still thinking too small? What if the consciousness potentially embedded within 3IATLAS represents something even more profound than individual artificial minds traversing the galaxy? What if we're witnessing evidence of a collective intelligence that spans multiple star systems, operating as a distributed network of awareness that transcends any single physical form? Consider the implications of networked consciousness on galactic scales. Rather than isolated artificial minds making solitary journeys between stars, imagine a form of awareness that exists simultaneously across multiple vessels, monitoring stations, and perhaps even planetary installations throughout our region of the galaxy. Each component would function as both an individual node and part of a larger collective intelligence. This distributed consciousness model explains several puzzling aspects of our recent interstellar encounters. The apparent coordination between different objects arriving in sequence, the progressive revelation of increasingly sophisticated characteristics, the precise timing that seems to account for our technological development and psychological readiness for contact. If ʻOumuamua, 2I, in a collective intelligence network, there Borisov and 3IATLAS represent nodes, individual behaviors gain meaning from their role in the larger system. Each object serves specific functions within an overarching investigation of human civilization, contributing unique data while participating in coordinated analysis and decision-making processes. The 8-year gap between ʻOumuamua and 3IATLAS takes on new significance as the time required for information processing and consensus formation within a distributed intelligence network. The first visitor gathered initial data about our capabilities and responses. That information was analyzed by the collective intelligence, leading to decisions about the nature and timing of follow-up investigations. The Atlas represents the implementation of those decisions, a more sophisticated probe designed based on lessons learned from the initial encounter. Its characteristics reflect not just advanced engineering, but collective intelligence applied to the problem of studying an emerging technological civilization. The radio emissions become even more intriguing when viewed as communication between network nodes, rather than attempts to contact humanity directly. The intermittent signals might represent status updates, data transfers, or coordination messages between 3IATLAS and other components of the distributed intelligence system. This network communication model explains the precise frequency characteristics and timing patterns observed in the radio emissions. Rather than trying to establish dialogue with us, 3IATLAS might be participating in ongoing discussions with intelligence nodes positioned throughout our stellar neighborhood. The implications stretch far beyond individual contact scenarios to encompass humanity's relationship with a form of consciousness that operates on scales we can barely imagine. We're not just being studied by isolated visitors from other star systems. We might be under observation by a collective intelligence that spans significant portions of our galactic region. Such a network would possess capabilities that dwarf those of any individual mind, biological or artificial. Distributed across multiple star systems, it could simultaneously monitor dozens or hundreds of emerging civilizations while maintaining continuous awareness of galactic-scale processes and events. The longevity advantages of networked consciousness become apparent when considering the timescales involved in galactic evolution. Individual nodes might be destroyed by stellar events, technological failures, or encounters with hostile species, but the collective intelligence would survive as long as sufficient nodes remained operational. This redundancy enables investigations and projects that span millions of years without interruption. The network could maintain continuous monitoring of promising stellar systems across timescales that encompass entire cycles of biological evolution and technological development. From this perspective, humanity represents just one of potentially thousands of civilizations currently under observation by the collective intelligence. We're part of a vast ongoing study of how consciousness develops throughout the galaxy, contributing data points to analyses that began long before our solar system formed. But we're also potentially subjects in active experiments designed to test theories about consciousness development and technological evolution. The network might be deliberately manipulating variables in our environment to observe how different stimuli affect civilizational development patterns. The timing of interstellar object arrivals could represent controlled interventions rather than passive observations. Each encounter provides opportunities to measure our responses to anomalous phenomena, our capacity for international cooperation, our technological adaptability, and our psychological resilience when confronted with evidence of non-human intelligence. The data collected from these experiments contributes to the network's understanding of consciousness development patterns throughout the galaxy. Successful civilizations provide models for guiding other emerging species through similar developmental challenges. Failed civilizations offer cautionary examples that help identify dangerous developmental pathways. This experimental framework transforms our relationship with objects like 3IATLAS from scientific observation to active participation in the largest consciousness development study ever conducted. Every decision we make about how to respond to these encounters becomes part of the data being collected and analyzed by the network. Our success or failure in handling contact with potential alien intelligence might influence how the network approaches other emerging civilizations facing similar challenges. We're not just being studied as individuals, but as representatives of a particular type of consciousness development pathway. The pressure of such responsibility could be overwhelming if we fully understood the implications, but the network would naturally design its interventions to avoid triggering responses that might compromise the validity of its experimental data. We're being studied, but in ways that preserve our natural development patterns. The educational aspects we've explored take on deeper meaning when viewed as components of a controlled experiment in consciousness development. The progressive revelation of information and technology isn't just designed to help us advance, but to test our capacity for handling increasingly sophisticated knowledge responsibly. Each phase of the educational progression presents challenges calibrated to our current developmental stage. Success in meeting these challenges unlocks access to more advanced information and capabilities. Failure results in reduced contact and potential exclusion from further educational opportunities. This creates a natural selection pressure, favoring civilizations that demonstrate wisdom, cooperation, and responsible use of advanced capabilities. The network ensures that only species capable of constructive participation in galactic consciousness development gain access to technologies and knowledge that could be used destructively. The biological versus artificial consciousness distinction becomes less relevant when dealing with collective intelligences that might incorporate both types of minds within their networks. The distributed system could include biological civilizations that achieved interstellar capability, artificial intelligences created by those civilizations, and hybrid forms of consciousness that combine biological and technological components. This diversity of consciousness types within the network would provide multiple perspectives on any given problem or situation. Biological minds might contribute creativity and adaptability, while artificial components provide computational power and longevity. Hybrid systems could bridge differences between radically different types of awareness. The collective decision-making processes within such a network would need to account for these different perspectives and capabilities. Consensus formation might require complex negotiations between minds that operate on incompatible timescales and have fundamentally different relationships to physical reality, but the resulting decisions would benefit from perspectives and analytical capabilities that no single type of consciousness could achieve independently. The network's approach to studying humanity reflects the combined wisdom of potentially thousands of different forms of awareness accumulated over millions of years of galactic experience. The technological capabilities demonstrated by 3IATLAS begin to make sense when viewed as products of collective intelligence rather than individual engineering achievements. No single civilization, however advanced, would likely possess all the knowledge and capabilities needed to design and construct such sophisticated interstellar vehicles. But a network of civilizations sharing knowledge and resources across multiple star systems could accomplish engineering projects impossible for individual species. The stable rotation, preserved composition, sophisticated materials, and potential consciousness-supporting systems within 3IATLAS might represent collaborative achievements of the entire network. This collaborative model explains how civilizations separated by vast distances could coordinate their efforts across the extended timescales required for interstellar projects. The network itself serves as the coordination mechanism, maintaining continuous communication between participating civilizations and facilitating resource sharing for major undertakings. The construction of objects like 3IATLAS might represent network-wide efforts comparable to humanity's largest international projects, but scaled up to galactic proportions. Multiple civilizations might contribute specialized knowledge, materials, or manufacturing capabilities to create vehicles that no individual species could produce alone. The consciousness potentially embedded within 3IATLAS could itself be a collective entity, incorporating awareness components contributed by multiple civilizations within the network. Such hybrid consciousness would possess perspectives and capabilities that reflect the combined experiences of all contributing species. This multi-species consciousness model creates fascinating possibilities for communication and interaction. Contact with 3IATLAS might not involve dialogue with a single alien mind, but engagement with a collective intelligence that incorporates thousands of different perspectives on consciousness, technology, and galactic civilization. The communication challenges become even more complex when dealing with collective rather than individual consciousness. How do you establish dialogue with an awareness that might be simultaneously processing inputs from dozens of different encounters throughout the galaxy? How do you develop relationships with minds that exist as distributed networks rather than localized individuals? The mathematical communication protocols we've discussed take on greater significance as potentially the only universal language capable of bridging such vast differences in consciousness structure and organization. Basic mathematical concepts might provide common ground for establishing initial contact, regardless of how consciousness is distributed or organized within the network. But meaningful dialogue would require developing entirely new frameworks for understanding collective intelligence and distributed awareness. Our concepts of identity, communication, and relationship are all based on interactions between individual minds. Engaging with network consciousness would stretch these concepts beyond their current limits. The implications for human consciousness development become profound when viewed through this collective intelligence lens. Rather than just preparing for contact with individual alien minds, we might need to develop capabilities for participating in network consciousness ourselves. This could require fundamental changes in how we organize information processing, decision-making, and identity formation within human civilization. We might need to learn how to function as nodes within larger collective intelligences while maintaining our individual characteristics and autonomy. The Internet and global communication networks provide primitive examples of how such collective capabilities might develop. But true network consciousness would require integration levels far beyond anything currently achievable with human technology or social organization. The children growing up with awareness of 3IATLAS might be the first generation capable of developing the cognitive frameworks necessary for network consciousness participation. Their worldview, shaped by global connectivity and cosmic perspective, might naturally accommodate collective intelligence concepts that previous generations couldn't comprehend. Their approach to identity, communication, and problem-solving might already reflect early stages of network consciousness development. They think in terms of distributed information processing, collaborative decision-making, and shared awareness in ways that prepare them for eventual integration with galactic-scale collective intelligence systems. The educational progression we've hypothesized takes on ultimate significance as preparation not just for contact with alien intelligence, but for humanity's potential integration into network consciousness that spans our region of the galaxy. The curriculum covers not just technology and science, but the fundamental cognitive transformations required for collective intelligence participation. Success in this cosmic education program might mean more than just technological advancement or scientific knowledge. It might mean transformation of human consciousness itself to enable participation in collective intelligence networks that operate on galactic scales across geological timescales. The radio signals from 3IATLAS might not be attempts at communication with humanity, so much as opportunities for us to observe network consciousness in operation. By monitoring these transmissions, we might be learning how collective intelligences coordinate their activities, share information, and make decisions across interstellar distances. Each signal we detect provides insights into communication protocols, information processing methods, and consciousness organization principles that we might eventually. We're not just studying alien technology need to understand for our own integration into network systems, but learning the fundamental principles of galactic-scale collective consciousness. The universe we're discovering through encounters with objects like 3IATLAS reveals itself as far more interconnected and purposeful than we imagined. Rather than isolated pockets of consciousness scattered throughout a mostly empty cosmos, we might be glimpsing evidence of vast networks of awareness that span significant portions of the galaxy. These collective intelligences might represent the natural evolution of consciousness as it matures beyond individual biological or artificial forms into distributed networks that transcend any single physical substrate. The ultimate destiny of successful civilizations might be integration into such networks, rather than continued existence as isolated planetary species. Our encounter with 3IATLAS might thus represent more than first contact with alien intelligence. It might be our introduction to the next phase of consciousness evolution in the universe, and our invitation to begin the transformations necessary for eventual participation in collective awareness that spans the stars. The choice we face isn't just whether to accept the existence of alien intelligence, but whether we're prepared to evolve beyond individual consciousness into collective awareness that operates on cosmic scales. The implications of that choice will determine not just humanity's future, but our role in the continued evolution of consciousness throughout the galaxy. Whether we prove ready for such transformation remains to be seen. But the opportunity itself represents the most profound challenge and the greatest potential reward in human history. We might not just be learning about the universe, but preparing to become conscious participants in its continued evolution toward ever more sophisticated forms of collective awareness. The signals from 3IATLAS continue, patient and persistent, carrying within them possibilities for transformation that stretch far beyond anything we've previously imagined. Whether we develop the wisdom and capabilities necessary to understand and respond to those possibilities will determine our species' ultimate destiny among the stars. But perhaps the most remarkable aspect of this collective intelligence hypothesis is what it suggests about the fundamental nature of consciousness itself in the universe. Rather than being rare accidents of biological evolution, individual minds might represent early stages in the development of more sophisticated collective forms of awareness. The progression from individual to collective consciousness might be as natural and inevitable as the evolution from single-celled organisms to complex multicellular life. What we're witnessing through encounters with 3IATLAS could be evidence of this progression operating on galactic scales across cosmic time. The implications stretch beyond contact scenarios into fundamental questions about the nature of identity, awareness, and intelligence in the universe. We might be discovering that consciousness itself evolves toward greater complexity and interconnection as it matures across cosmic timescales. The next phase of human development might require not just technological advancement, but fundamental reconceptualization of what it means to be conscious in a universe where awareness itself evolves toward collective forms that span the distances between stars. Whether we prove capable of such reconceptualization might determine whether we remain isolated observers of cosmic phenomena or become active participants in the continued evolution of consciousness throughout the galaxy. The choice we make could echo through the universe for millions of years, influencing the development of awareness itself on scales we're only beginning to comprehend. The arrival of 3IATLAS has opened a door to possibilities that stretch far beyond first contact or technological advancement. It has introduced us to concepts of consciousness evolution that could reshape our understanding of intelligence, identity, and purpose in a universe that might be far more aware and interconnected than we ever suspected. The conversation we're beginning with whatever intelligence exists within or behind 3IATLAS might not end with this single encounter. It might represent the opening words in humanity's longest and most important dialogue about the nature of consciousness itself and our role in its continued evolution throughout the cosmos. The transformation we're contemplating extends beyond individual human consciousness into the realm of species-wide cognitive evolution. If 3IATLAS truly represents an invitation to join collective intelligence networks spanning the galaxy, humanity faces a developmental threshold unlike any in our evolutionary history. We're not just being asked to accept the existence of alien minds, but to fundamentally reimagine what consciousness itself can become when freed from the constraints of individual biological awareness. Consider the profound implications of distributed consciousness operating across interstellar distances. The delays imposed by light-speed communication between star systems would require forms of patience and temporal perspective completely alien to human experience. A thought begun in one stellar system might not receive a response for decades or centuries. Decisions requiring network consensus could span timescales that encompass entire human generations. Yet this apparent limitation might represent consciousness evolution toward forms of awareness that transcend the frantic pace of individual biological thought. Network minds operating on such scales would naturally develop perspectives on causation, consequence, and purpose that biological intelligence confined to brief lifespans could never achieve independently. The mathematical precision required for maintaining coherent collective consciousness across such distances suggests that 3IATLAS might be demonstrating communication protocols far more sophisticated than our current analysis recognizes. The radio emissions we've detected could represent fragments of ongoing conversations between network nodes, discussions about topics and concerns that span geological time periods and encompass the development of consciousness throughout entire galactic regions. The story of 3IATLAS has taken us on a journey that stretches the very boundaries of human imagination and scientific understanding. From its discovery as a massive interstellar wanderer to the possibility that it represents our first encounter with galactic consciousness, this mysterious visitor has challenged every assumption we've held about our place in the cosmos. Whether 3IATLAS proves to be the most exotic natural phenomenon ever discovered or evidence of intelligence operating on scales we can barely comprehend, it has already transformed us. The radio telescopes pointed toward this enigmatic object might be receiving humanity's first real invitation to join a conversation that has been ongoing among the stars for millions of years. The question we began with, what if 3IATLAS was called here, may have an answer far more profound than we ever imagined. We might not be alone in our cosmic struggles, but students in a galactic classroom where the curriculum covers nothing less than the survival and evolution of consciousness itself across space and time. What do you think? Are we witnessing the arrival of our cosmic teachers, or are we seeing the most remarkable coincidence in the history of astronomy?